First new thing for today, the average value of a function. If f of x is continuous on the interval a to b, then the average value of f on the interval is 1 over b minus a times the integral f of x dx from a to b. Our first example, find the average value of the function f of x is equal to 3x squared plus 1 over the interval 0 to 3. So starting with that formula, plug in what needs to be plugged in. A is the lower bound, b is the upper bound, and our f of x is 3x squared plus 1. Basic power rule gets us from here to here. 3x squared integrates to 3x to the third over 3. 1 integrates to 1x. Clean that up a little bit. We want to evaluate x to the third plus x from 0 to 3. Plug in a 3, plug in a 0. Subtract those results. That gets us to 30. And then lastly, 1/3 of 30 is 10. The average value of the function is 10. Second new thing for today, mean value theorem for integrals. If f of x is continuous on the interval a to b, then there exists a number c in the closed interval a to b such that this here is true. This last part here, the last part of the mean value theorem for integrals, can be rewritten as, if we divide both sides of this equals by b minus a, it equals this right here. The reason why we're doing that is that allows us to use the first thing that we learned. The left side of the equals is just the average value of the function. The right side is f of c. This version more directly connects to the average value of the function and is better suited to solve the types of problems we will be addressing. Interpreting this in a slightly different manner than our text, the mean value theorem for integrals tells us that if conditions are met, there exists a c value in the interval such that the function equals its average value over that interval. Our second example, same function, same interval. What it's asking us for, find the value of c guaranteed by the mean value theorem for integrals over the interval, or another way to ask the same question, find all values of x in the interval for which the function equals its average. So the left-hand side here, we've already done that. That's the average value of the function. Refer back to the top half of the page. We've calculated that to be 10. The right side of the equals f of c, we're just going to take c, plug it into our function, and that gets us to here. A couple basic algebra steps gets us c values of plus or minus root 3. The negative root 3 is outside of our interval. That's extraneous. We're going to disregard that. The positive root 3, we want that. So there's two ways we can answer this question. Based on the wording up top here, we would answer it as c equals root 3 is the value guaranteed by the mean value theorem for integrals, or if we're working off the wording on the bottom, x equals root 3 is the value at which the function equals its average. All right, let's take a look and see what this represents. So what we have here is this is part of our function, 3x squared plus 1. I marked off the endpoints of the interval. When x is 0, y is 1. When x is 3, y is 28. So the smallest y value is 1, biggest y value is 28. When you're referring to the value of a function, that's what you're referring to, the y values. Well, we have an infinite number of points between 0, 1, and 328. So we're looking for the average of an infinite number of y values. Traditional algebra will not allow us to do that, but calculus will. That's what we did on the top half of the first page. We found out that the average of all those y values that are there are 10. All right, adding a little bit more to the graph. The graph to the left shows the function over the interval, but now it drew in the line y is equal to 10, and the intersection point, root 3, which approximates to about 1.732. That's the point of intersection here. So, where that line, horizontal line, intersects the curve, that represents the x value at which the actual value of the function equals the average value of the function over that interval, and that y value represents what that average actually is. Now, as far as what we need to know for this class, that's pretty much enough. Other things that are important in calculus that we're going to talk about briefly here. If we look at this part of the average value theorem right here, average value formula rather, okay, the integral of 0 to 3 of 3x squared plus 1, that's equal to 30. That represents the area between the curve and the x-axis between the x values of 0 and 3. So I'm going to highlight that. That 30 is roughly this area right here. All right, now another interesting result of the mean value theorem, which is emphasized in other areas of calculus, is this rectangle that gets formed here. Its area is the same as the area under the curve. For what we do in this class, that's not as important as other applications. What's most important for us is being able to, given a function with an interval, find its average value. Given a function with its interval, find that x or c value, depending on how they word the question, at which the actual value of the function equals the average value of the function over that particular interval. The next video is going to look at the calculator keystrokes in order to figure this out without going through what we went through on these 2 pages.